All right, today we talked about day 2 of percent of increase and decrease, and this is where this idea of percent error gets introduced. So this would be the percent that an estimated quantity differs from the actual amount. So percent error is amount of error over actual amount. So think about it this way. If we have a cookie jar here, okay, and we have, 10 cookies, okay, I know that the actual amount of cookies is 10. You're going to estimate that there are 8 cookies in the cookie jar. Well, what's the amount of error? The amount of error would be 2 because 10 minus 8 is equal to 2. There's actually 10 cookies and you were off by 2. Okay, so 2 over 10 would be a 20% error. So you were off by 20%. And that's what percent of error means. Okay, so let's look at this one here. I'll rewrite it again. Percent error equals amount of error over the actual amount. So it says here that you estimate that the length of your classroom is 16 feet. So this is your estimation. This is your estimation, your guess. This is what you think, okay? That number is not going to be used. Then we look here, it says the actual length is 21 feet. Here's that keyword actual. Okay, so I know that if I'm going to talk about my ratio, the actual amount is 21. Well, how off were you, right? You guessed 16. So if we take 21 and we subtract 16, right, we're going to get 5. So you were off by 5 feet. So we need to figure out what percent 5 over 21 is. So take your calculator, 5 divided by 21. We'll just round to the nearest tenth since that seems to be what we've been doing. 0.2380. Okay, change it to a percent. So we have a 23% error. And that's the word you use. Oops, I forgot my percent sign. We don't put increase or decrease. We put the word error. Okay, so it's super duper similar. You just have to figure out how far off were you from your estimation to the actual. Okay, and then find the percent. So here's another one here. It says that you estimate that a baby pig weighs 20 pounds. Okay, so this is your guess. And it says the actual weight of the baby pig is 16 pounds, right? So remember, it's amount of error over actual. What do we know? We know that the actual weight is 16 pounds. You guessed 20, right? So 20 minus 16, that's the ratio you're looking for. That's 4 over 16. A lot of you know that that's 1/4, right? Which then would make you all know that this is a 25% error. Hopefully we can do that one without calculators. All right, so amount of error over actual. So you'll have a couple of those, not too much, but I just wanted you to see what it was all about. Now, going back to this idea of percent of change, right, which percent of change equals amount of change divided by original value, which we can shortcut and write it's the difference over the original. But these just kind of stepped it up a notch and made them a little bit harder. This is 3/4 to 2/5. And I know some of you are going to say, can't I just deal with decimals and put it all in a calculator? Sure. However, you need to know how to work with your fractions. Sometimes you're going to have fractions that are repeating decimals, so you have to work with them fractionally. So keep trying and work with your fractions. I know that 3/4 is greater than 2/5 just because we know our numbers and number sense and all that stuff. So I'm going to circle this one because this is my original. And if I'm going from here to here, I also know that that is a decrease. All of the steps are exactly the same. You just have to do your fraction work, okay? So the first thing we have to do is find the difference. 3/4 minus 2/5. Yes, you need to find common denominators. times 5 times 5 times 4 times 4. So 15 twentieths minus 8 twentieths is 7 twentieths. So this right here, this is the amount of change, or the difference, if you want to call it that. So now we're going to take our difference, our amount of change, and we're going to put it over our original. And you can see that we now have a complex fraction, right? 7 twentieths divided by 3/4. This is 7 twentieths times 4 thirds. Okay, and you can simplify if you want, but you don't have to, because in the end, you're just going to divide to change it to a percent. Okay, so this would be equal to 28/6. Wait, I messed up. Erase that. I'm glad I caught myself before I finish this entire video. 7 twentieths. Okay, so always double check. Now I'm going to cross cancel because it's just hard for me not to. This is a 1 and this is a 5. So I know that I have 7 over 15. Okay, 7 over 15. Punch that into your calculator. 7 divided by 15. Multiply that by 100. We are rounding to the nearest tenth of a percent. This gets you 46.7% decrease. Okay. All right, moving on to part B. Again, there's my original. It's what we start with. 7/8 I know is almost 1, and we're going to 1/2. So I know that this is a decrease. Now think about that. 7/8 is almost 1, because 1 would be 8/8. And we're dropping that down to half. So we should know that it's somewhere around a 50% decrease. Okay? So again, you have to do your subtraction. 7/8 minus 1/2. Common denominator is 40. Times 5 times 5, this is 35. Times 20, this would be 20. This is equal to 15 40ths, and you're more than welcome to simplify. Okay, this is the amount of change. The math is exactly like yesterday's work, percent of change, just not as user-friendly numbers, okay? So I know that the amount of change is 15 40ths all over the original amount, which is 7/8. Make this line a little shorter. And I know that that's equal to 15 40ths times 8/7. Now I can do some cross-canceling. This would be a 1. This would be a 5, and I get 15 over 35, which again, you could simplify to 3/7, but you don't need to, because you're just going to divide 15 divided by 35, multiply by 100 to make it a percent. This is going to be 42.9% when we round to the nearest tenth decrease. Okay, so everything is the same. It's just not as friendly of numbers. Difference over original. All right, now we look at this problem here, and we're going to utilize information. So it says the table shows population data for a community. It gives us 2 years, 2007, 2013. Question A, what's the percent of change from here to here? Well, we know it's an increase, and we know that 2007 is going to be our original. Okay, so the first thing we have to do is find the difference. And you can look at these numbers pretty easily and see that the difference, right? The difference is 20,000 over the original, which is 118,000. Okay, and then this as a percent, 20,000 divided by 118,000. And we'll go to the nearest tenth of a percent. Okay, this ends up being 16.9%, and we know that is an increase. Okay, so nothing's changed with that. Now, part B says use this percent of change to predict the population in 2019. Well, if we wanted to make this 2019, and we could look at our table, I know from 07 to 2013, this was 6 years. And in 6 years, the population increased 16.9%. Well, I know that this is another 6 years, so we can predict that it's going to increase another 16.9%. So I'm going to find 16.9% of 138,000. And that gets me 23,322. So this is going to be the increase of population. Okay, so I need to take this number and add it to the existing population, and then that will give me our estimated population for 2019. Okay, so we know that the percent of change from 2007 to 2013 was 16.9%, and that happened over the course of 6 years. So all we did was increase 2013's population by another 16% to give us that answer right there for part B. Okay, so utilizing percent of change to make predictions, a little bit more complicated numbers to work with, and then this idea of percent of error. Okay, hope that helped.